Thank you guys so much for joining this, this security talk. My name is Zach Arnold. This is my colleague, Austin Adams. We both work for a company in the Bay Area called Ygrene Energy Fund. And we're going to be talking today about a little bit about our journey in security, specifically with cloud-native tools, and essentially attempting to demonstrate that, that Kubernetes is actually ready for the finance industry. So we're also going to be talking a little bit about achieving high security at scale with microservices in Kubernetes. So it is going to be a little bit beyond just Kubernetes as the execution environment and actually talking about securing containers. So really quickly, first, I should also mention, at any point, if you have a question, you can go to that link right up there. It is live, and send us a question. I'll obviously be answering questions at the end, but if you're not close to a mic or don't want to shout, you can submit your question there, and we'll attempt to answer it at the end if there's time, or certainly will be available in the corner. So what or who is Ygrene, and why do we focus on security? Ygrene is the word energy spelled backwards in English. I did not choose the name, but it is interesting to note. I found that out 6 months into my job, so that was good. We are a renewable energy. Slower. Yeah, we're a renewable energy financing company. Basically, we operate under the same or some laws that allow us to apply the financing as equity on a property, and essentially that gives us first lien position against a mortgage, and that means that we end up interfacing with governments because they're the only people who are allowed to levy property taxes, of which Ygrene becomes a tax in a way on a property, and that's how you repay the loan or lien. So we grapple with data integrations with other businesses, the contractors who are actually performing these improvements on properties, the governments that we're reporting to and working with to offer this financing, and of course the property owners who are giving us their sensitive information that we want to guard and protect. In regards to security, we're a lot like a mortgage banking provider in the sense of that's the kind of information that we need to collect for underwriting loans. So you can imagine credit, things like that are things that we have to hold on to and protect. But we're also in an emerging industry, so PACE, Property Assessed Clean Energy. PACE has no regulations as far as information security is concerned. There is one sentence, and it says, data must be encrypted in transit and at rest. And so for those of you who have dealt with any amount of security at all, that's sort of like the shrug emoji of security. It's sort of like, okay, great, well, what else is there? So security matters to us because we're a PACE provider that is aggressively focused on protecting our consumers and our property owners. It's extremely important to us that we keep them safe and that we not only don't allow them to make a fiscally irresponsible decision by getting our financing, but also that they don't put their data at unnecessary risk when they work with us as a company. So I guess then, if that's us, what's this talk going to be about? What we're looking for you guys to get out of this is somewhat of a case study for Ygrene and how our security evolved as we adopted cloud-native tools and solutions to a lot of what we did. We were born in the cloud about 6 years ago, so we never really had to worry about migrating legacy systems, but we did have to deal with migrating legacy mindsets when it came to dealing with cloud-native practices. We want to encourage you that Kubernetes can and does work for the finance industry. It is safe, and that we're actually hoping that a lot of the concepts that we're going to be showing here, and in our implementation actually, will be transferable to you and your environment, regardless of what industry you're in. And so to frame kind of the next piece of our talk, we're going to be speaking a little bit on like what we're calling the 4 C's of where we look at security: code, containers, clusters, and the cloud. Those are arbitrary lines that we drew just so that we could have areas of focus. It's obviously very fluid in there, and we're going to talk about various pieces of all of it. But first, we're going to be speaking about code and containers and how it pertains to the pipeline, which is really where we begin to focus on security and automating as much as humanly possible. And then we'll talk about the risks to Kubernetes clusters and the tools that already exist either in Kubernetes core or in the cloud-native ecosystem that help to deal with these risks. So first, I guess, to talk about code and containers is my good friend and colleague, Austin Adams. So why don't you welcome him while he comes.
Thanks. Don't clap too much because we want to leave time for questions at the end. So So our journey with containers started, I don't know, a year and a half ago, 2 years ago. We were using them in development, sort of. And I remember the first time I used Docker, I was completely confused, or containers rather, and didn't do it the right way. And now I carry my lunch in a Docker container to work every day. So for us, when we started getting into containers, we realized that they're awesome in development. They solve so many problems, but then they add maybe just as many problems in production in terms of more overhead for security to manage and unknown things that can happen with a Docker container and a single point of failure at the Docker daemon. So when we started getting into containers, we identified kind of three really important risks that we wanted to mitigate, and some scenarios that go along with those risks. You push a Docker image and the next time you push, the base image updated because I was using the latest tag. Now I have no idea what version of the OS I'm running and what version of the packages I'm running. A developer pushed a container from their laptop and for whatever reason, they have a M file or some environment variables or some keys that were in their local build context. Now they're in the container, now running around, and we're going to have to pull those containers and maybe even cause downtime, which is always bad. Or we're just going to have to deploy and delete and scrub logs and things like that. There's a certain amount of Docker is so easy, so it's easy to just kind of go with a naive approach and end up not knowing that you had X package in your base image because you just used the regular base image that might have come with some random package that nobody actually needs, like image magic or something like that. I have no idea, or some obscure shell. What we're trying to do at Ygrene, and it's very much a journey, but what we've seen some success and gotten some value out of is creating a few policies that match up to those risks that we identified. And our security iteration is to try to automate the enforcement of those policies. So those policies in name are, and this is like really small, so I'm going to look at the screen, which is against the rules, but whatever. A Docker file policy, our application and vulnerability policies, and an identity policy. So briefly, what that is Docker file policy is everything about the image as it's built. Anything in the Docker file is up for our build server to lint and to review and to tell you that's wrong. A CVE policy, what sort of CVEs, do we even know what the vulnerabilities inside of our Docker image or our dependencies are? Do we even have any clue what we're about to ship to production? And then if we do know, what are we willing to accept? What's too hard for us to refactor? Or what is our policy around? Do we allow low risk vulnerabilities versus high vulnerabilities? And just getting some awareness there. And identity, who's allowed to push to production? Or who is allowed to build a container? Is it only build servers? Is it developers? Are they allowed to build containers? Who has to review a container before it goes out to production? These are questions that we need to ask because we have to provide some sort of reporting and we have to provide some sort of auditing on everything that's happening. We're not processing transactions or anything, but we're dealing with a lot of customer data. So if we have a breach, we've got to be able to triage through and find out who exactly caused that, how it happened, and how we can tell the banks that work with us and the investors that work with us that we're not going to do this again, which that's not happened, but with Docker at least. So to kind of illustrate how we're automating those policies or enforcing those policies, I'm going to walk you through kind of a typical security build through our pipeline. It's not implementation specific. I'm providing lots of different tools, and I'm not going to go into exact detail of how we do it, partly because I can't, and otherwise because I just want to provide options. We use a mixture of open source tools and stuff that we've created that we would love to open source after we get the blessing of our company and everything to do so, that are trying to enforce our Docker file policy and our CVE policy and our identity policy. So whenever a developer wants to make a microservice, a new microservice, or a service at all that has a Docker container associated with it, they will, have to have a build plan. That's where everything starts. That's how we do development. And they will have to have a Docker file. So when their Docker file gets pushed up, when they make a commit to their service, we use a mixture of different Docker file linters. And is that the slide up there? Yeah. And on the screen, and you can download the slides, are links to some really good ones. And the goal here, at the end of the day, is not about the tools. It's about achieving the CISP standards for Docker build. There's a section within the Docker benchmark from CISP, am I saying that right? That specifies what a Docker file should have and what a Docker file shouldn't have. And it's so incredibly easy to lint. There's some tools. One of these tools is written in Haskell, so go you. I love Haskell. Although, I don't know. You guys know what I'm saying? It's incredibly easy to use these tools, and so my whole goal with kind of leading this security effort in my company is I don't want to be caught shipping something I could have avoided. Like, there's these security experts spending their entire careers working on finding vulnerabilities in open source projects and software. And so if I'm ignoring the best practices and the lists of CVEs from other people, then I'm doing my whole company a disservice when I knew about them. So that's how I see it. So we're using these linters and some homegrown tools to put policy around what base images people can use. And avoiding best practice screw-ups like switching to root and using root as the final user, not removing those weird set GUID binaries and things that have high permissions that can do weird stuff. And this isn't about runtime. This is focused on build time. Also, with these tools, we're enforcing, hey, maybe every pod of a certain data classification has to use Red Hat. They can't use Debian or whatever it might be. They have to use, when you're classifying your data as, secure, top secret, whatever it might be, this microservice might deal with super secure data. So we want it to use a version of Red Hat. Maybe we've got a license with them or something like that. Something that is security focused. Whereas my Grafana image, I don't really need to have Red Hat or whatever your organization provides. That's our recommendation, is to formulate those kind of policies, especially if you're working in finance and you need to actually report on some of that stuff. The other thing is just these linters can help you identify if you're just putting way too much in your Docker container. And I encourage you to look at these projects and even contribute if you have some ideas there. The next step actually relates to the application and CVE policy, and this is by no means a new thing. Maybe all of us are doing this already, but scanning your dependencies of your code. I mean, maybe people aren't doing this still, but do it. And lock down your versions. It's just like Docker. You don't want the next build to be pulling some random version of a dependency and then realize that you have no idea what's in your container. Maybe it's not even unsecure, or maybe it doesn't have a vulnerability, but being able to be 100% sure what's inside of your container is actually really important. It helps with triage and debugging, and if something is to happen, then you can point back. Otherwise, you don't really know what's going on until you check. So being 100% sure what's going out before it goes out is actually really important. So again, the goal is to look for clear security issues. So we're using static code analysis tools. Regardless of language, there's a lot of them. OWASP has some amazing scanners you can use, and then we're also scanning our dependencies. We're doing passive scanning just to get alerts if there's a new CVE that might relate to our code at rest, but then also an active scan of the dependencies as a part of the build process and kicking things out if they contain, hey, there's a patch available for this high profile vulnerability, and you just need to update. So we're creating this security culture through the pipeline by giving people red builds when they try to push stuff. So it's up to the developer to go back and say, oh, I need to update this, so that they can see the choices that they make actually affect the organization's security. So then if everything's green on the Docker file policy and the application dependency check, the next step that we do is we actually build the container. We have to build it, turn it into we have to build the Docker file, turn it into an image, I think is the right terminology. But we do that in a specific way. Whenever we build, we turn Docker Content Trust on. And what that means is the Docker CLI tool will not allow us to build a base image, to use a base image, a from, that does not have signed metadata. So what that's doing is that's giving us cryptographic guarantees that the author of this base image is actually who I think it is, depending on lots of factors. If their keys get compromised, the way that Notary works is it's very easy to Docker Content Trust and Notary, they're the same thing, by the way. It's very easy for them to revoke those keys and keep going, and they can have some transparency there. But what we want to do is establish that trust with those very restricted set of base images. Maybe it's the Red Hat image, or it's the Amazon Linux image, or the Debian image. Those base images that they're being signed by the owner of a certain set of private keys that they are keeping secure. So they're saying, I have these keys, I'm signing this metadata on the Notary server on Docker Hub or whatever Docker registry we're using. We're pulling that metadata and actually validating that it's correct before we do anything. So if a developer does get past the image whitelist part in the Docker file policy, and there is some Notary issue, maybe the Notary client detects some weird issue, the cryptographic metadata, the signed metadata is coming back and the hash of the base image is not matching up, then it's going to tell us. So we've just mitigated the Debian Docker Hub repository getting their credentials got lost or got into someone else's hands, and some malicious part of an image came in through some hack or something. So we're able to be pretty sure that that's not going to happen to us because we're using Notary at build time. The other things that we're doing, and we're trying to automate this next piece, is sometimes service owners or a team might need dependencies that are outside of code dependencies or OS dependencies. They might just be a curl request or a wget request. We are trying in the linting side and actually at build time to make sure that developers are checking the checksums, the hashes of those. And I know that's pretty straightforward, but it gets missed a lot of times because Docker is just so easy to make something, and you're just pasting in curls and getting all these dependencies. But making sure that developers have a little bit of thought in what they're doing, going out, getting the checksum for the version that they want and putting it in. It helps them to pin to a specific version so they're not getting an auto update. And secondly, it helps us understand that that checksum isn't changing. And obviously there's some things that can happen. There's some weird release things where they might change the checksum for a specific release, same version number or something. But we can handle those. Those are like the the oddball cases. They're not the norm. So we're trying to automate that. Maybe if you have a tool that forces Docker curl commands to check checksums, what we're just going to provide is a little script that everyone has to pull out of band dependencies using this script, which will automatically check a checksum. And then the other thing is just always squash your images. That will delete any layers that you might not want in there. For example, the computer stopped.
This is security default. That was a joke.
Yeah, they know. It just wasn't funny. Jeez, man.
It's a very long password.
We're really secure here. Our password policy is like impossible. Someone's gonna like record the keystrokes and know what your password is or something.
You should.
Oh, all right. Are we back? Okay. Thank you, Zach, for having a 1,000-character password. Yeah, so we squash. So, for example, a lot of times we keep our dependencies private. We have stuff we can't open source right now or whatever. And so we need an SSH key, a private key. It's a pretty limited permissions key, but Also, we don't want this code getting into wrong hands, and also we don't want this key in the container at runtime. So this may be straightforward. It's on every blog out there how to squash your images. So I probably don't need to tell how to do it. If so, you can Google. But it's easy to turn on. You basically have to enable an experimental flag in the Docker daemon, and then you can squash your images. What it will do is it basically just shoves everything into a tarball at the end, one tarball instead of a sequence of zipped or compressed files, so that any operations that you might have deleted, like a file getting added in and then deleting, that's all just gone. So it's just a normal compressed folder, so that key is actually 100% gone. So after we build and we have ensure that there's some trust with the base image creator, which most of the time the base images that developers will be using will be DevOps department provided images, because we provide a lot of those intermediary images for them, will be signed by us. So that's not a big deal, but it's still good to do, because we have our utilities in our CI, like our Grafana images has a thing for CI. Maybe I shouldn't have told you we use Grafana. I'm not sure what I can say, what I can't say. The next one is we go into some security testing, which is my favorite part. It's trying to automate what we're okay with shipping in terms of vulnerabilities that have already been found. So what we do is we use tools like CoreOS Clair and Dagda and other image scanning systems, both passively and actively in the pipeline. Passively to, once we've pushed an image, if there's a vulnerability found within the next couple of days, we'll get an alert. Hey, these images are vulnerable, so then we can take action. But then also actively within the build to make sure that this image, before we push it, is not going to have any high, red vulnerabilities or even yellow, depending on your organizational, what you're okay with shipping. Then after we've done that, this is my favorite part. We use the Z attack proxy and we point it at the API docs of the microservice, and we see if the Z attack proxy can get in. So if you don't know what the Z attack proxy is, it's it's a really cool penetration tester thing that will use a bunch of already known patterns for bunch of different security vulnerabilities, and it will actually attack some port on your computer. So what we do is we spin up a Z attack proxy in Docker, and then we spin up our little service in a little environment in Docker, and we just let the Z attack proxy go to work. And so again, it's not going to find some 0-day thing maybe, but it's our attempt to never ship an Apache struts out of date now that Equifax has already been hacked by it or whatever. We don't want to be caught doing the same thing that the whole community has already fixed. So that's the goal here. You can get a lot of information on the links over there. So this is really fun. So that's why we came up with continuous hacking, like continuous integration, continuous hacking of your containers. It's kind of fun. And then the last step of the security round of our build process that all of our services go through is the identity policy. So and this actually we're reworking from yesterday, because we heard this really good talk from IBM guys on this, or IBM people on this tool they created called Porteros, which is a webhook admission controller that works with Notary to allow multiple keys to sign an image, and then you can do different types of admission based on namespace and based on keys. So what we do is we sign our images, and for specific environments we sign them with specific signers, right? So there's in Docker CLI, it's this notion of a signer, which is someone other than the root key, the root private key, that can sign an image, so a trusted signer. And then in Notary, it's the exact same thing, just a different name. It's called a delegation key. So Notary, or the Docker CLI, uses the Notary Go client to actually accomplish this. So what we're doing is we're not allowing images to go to production that haven't been signed with a specific key. But developers can play around in lower environments with whatever, but before a container is actually allowed to get into the production cluster, it has to go through some more rigorous examination. Sometimes some manual steps, sometimes just it's a matter of we just want to be sure that nothing's going on, nothing is evil inside that container. So we're using Docker or Notary to actually sign this. But one quick tip for Notary, and this is where I'm going to end, is if you're going to get involved with Notary, never, ever, 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 ever use your root or target keys. So, and you should learn, you can look at the docs to learn about how Notary works, but basically you're issued 1,000 different private keys, 2 of which are, I know, it's kind of crazy. We're working on that in the Notary project to make that better and easier to use. But you get a root key and a target key, and those can remain offline. You don't need them to actually sign images. You need them just to create these signer keys, these trusted keys. So if any of these delegation keys get compromised, because you have kept these root keys offline in like a flash drive or in a security device or something, you can actually revoke privileges on those keys. Those keys are derived from those other keys, but it makes it easy to recover from a breach. So you can be pretty sure that even if you do get a build server gets hacked and they get the key and they're signing images and pushing them, you can revoke those, and then you don't even have to delete them out of your registry. Your Kubernetes cluster, when it pulls that image, or your admission controller, when it pulls that, will recognize, oh, this key ID is not within the signers list on the Notary server, so I'm not going to let this image go through. So that's what we're doing in our build pipeline. I hope that's useful, maybe inspirational at least. And so obviously the container has to go somewhere. So to finish off the security that we're doing at Ygrene, Zach is going to talk about how we're doing it in the cluster in the cloud, actually running these containers. We've spent so much time making sure that they're secure.
Thanks, Austin. So I guess let's now talk about the last 2 C's, which are the cluster and the cloud. This is probably going to make the most sense. I was going to ask, actually, are there any sysops admins or DevOps folks in the or DevSecOps types? Okay, a few of you. Nice. You guys escaped. Wonderful. So the whole notion of running software in production is obviously nothing new to any industry. Stability is extremely important, and Kubernetes does a lot of that out of the box. But as far as running software securely in production, that is, it's actually been a growing field and growing every single day. I mean, the most hotly coveted position in the C-suite now is the CISO, the Chief Information Security Officer. So I guess let's talk a little bit about issues in Kubernetes for the risk adverse, or the people who are going to be running your clusters in production, the software. So it's important to note that the locus of control for you as a software operator, someone who deploys code onto the cloud, that is no longer you. That is Kubernetes. Kubernetes will be monitoring, restarting pods, deploying, scaling, handling a lot of those concerns for you. So there's a lot less control over that final resulting environment, which means you really have to nail what we spent most of our time on, which is the Docker image that eventually gets deployed onto the cluster. Security really starts in the build pipeline for us. So if you understand that the locus of control moves from you to the cluster, and the way that we think of the Kubernetes cluster is essentially it's a benevolent botnet. It's the command and control servers are the API masters, and the kubelets are the nodes. Which is kind of funny when you think about it, and then all of a sudden you're like, oh, I hope I never get compromised because it's a botnet. So it could become a malevolent botnet, and that's not obviously something you want. So I guess it's important to note that this is open source software, which means it's generally extremely well reviewed by a lot of brilliant people. Some of you here are even contributors. Thank you so very much. You've helped us to do well as a business, but that does not make it flawless. I mean, just 2 months ago with the host path mapping issue that was released as a CVE in Kubernetes was one of the more serious that happened, and there was a patch rolled out in about 24 hours. But that doesn't mean that every single cluster that had that vulnerability also had that patch. So it's extremely important that as a cluster operator, we at Ygrene, we're subscribed to every CVE mailing list that we can. The Kubernetes Announce is a group that they'll let you know if there's something coming in as a security vulnerability. Yeah, it's a Google group, so Kubernetes-announce. It's important to be aware of that, because if you're going to run software securely in production, but your underlying infrastructure is absolutely hosed, then it really doesn't actually matter how secure your container is, because your environment isn't. Also important to note that your attack surface essentially doubles when you're getting into Kubernetes, and that's one of the considerations that we had to make at Ygrene. Were we comfortable with that? Because traditionally, when you look at vulnerabilities and threat modeling, you're like, okay, I think that a vulnerability could come from the hypervisor or the VM, it could come from the network, or it could come from the software I deploy onto it. Well, with Kubernetes, you have not just that, but you have also a mini hypervisor called the Docker daemon, a mini VM, which is called a Docker container, a container networking interface, and of course, obviously, the software that orchestrates all of that. So that's a lot more places where stuff could feasibly go wrong. And that becomes a concern. And so it's improper cluster bootstrap and setup will cause security holes. So like if you're not paying attention to the billion levers and buttons that you can push in a cluster, or how those interactions work, then and we found out, like, okay, it's actually really easy to make stuff super insecure or unsafe in production. And then, of course, right now there's really no body responsible for the determining of regulatory compliance for Kubernetes clusters. I mean, there's a lot of people who have great ideas, and CISP and CIS are doing an awesome job of working on cloud-native standards, but really, like, inside of even Kubernetes, there's current discussions going on between all the SIGs of, like, who's really responsible for determining the overall security of this environment. So if those are the concerns, then here are some mitigations. A lot of these will be extremely familiar to those of you who run secure software in production. Kubernetes basically has abstractions for everything that you would traditionally run in a cloud. Here is a quick list. It's by no means exhaustive, but I'm going to run through it really quickly so we can get to some questions. We're running out of time. RBAC, role-based access control. It happens right after authentication in the API server. It works just like role-based access control. You can set up all of your principals, objects, verbs, just ensuring that whoever is talking to your Kubernetes cluster is allowed to do what it is that they just asked for. If they're trying to delete your production deployment of some extremely critical service, do they actually have the permission to do that? RBAC will help cover that. API server admission controllers. These are beautiful. Learn these, love these, build your own if you want to. API server admission controllers happen right after the authentication and authorization step of Kubernetes. It's essentially one more place where the API server can check to say, is this object okay to go into the cluster, or does something need to change? So it makes sense. There's a well-published set of defaults. A validating admission controller basically says, yes, no, this is allowed to go in. An example would be, is this pod trying to run Docker privilege mode? No, don't let it. And a mutating webhook, which was our friends over from IBM and Portieris, which was actually change the object to match the specification that you have defined before it goes into the cluster. There's debate on whether or not that's actually what you want to do, if you should just outright reject an API server request, because technically it changes before it goes in the cluster, so it's not exactly what you sent, but actually it works out in the case that IBM mentioned. Audit logging is new in 1.9. It's beta right now in 1.10. It's terrific. It is as good as you make it. So if you have a Kubernetes cluster and you're just passing around your kubeconfig file to everybody, and then that essentially makes everybody God mode on the cluster, that is probably not going to be super safe or helpful. And if you're doing issue diagnosis or triage, then every single request from the API server point of view looks the same. So that's not very helpful. It's good to partner that with an IDP like Heptio's AWS Authenticator if you're running an AWS, or CoreOS's DEX. And we'll talk about that in a moment. Network security policies, pod security policies. Essentially, they give you the control around your environment that we used to have with things like AWS security groups, or things like setting up SE Linux profiles. I won't go super deep into them because, like I said, we're running out of time. And then if that isn't enough control for you, scheduling, taints, and tolerations. These are actually kind of cool. Essentially, you can make sure that sensitive workloads and non-sensitive workloads are not co-scheduled. So even if you have a node compromise, there is still separation. So you wouldn't want a Drupal content management website running next to something that pulls credit. So then you can schedule those so that they take or tolerate, or you can do pod affinity or anti-affinity to make sure that they're not actually running on the same node inside of your cluster. So then you don't end up having a problem where if Drupal, which they had a 0-day a few days ago, gets hacked and someone runs a shellcode attack and somehow they manage to escape the Docker daemon, then they're running en route inside of your credit pulling service. Cool, so some external tools. Aquascanner's Kubench project. Thank you, Aquascanner, if you're here. They do CIS for the Kubernetes environment. It's pretty good. You basically can continuously check your conformance with the CIS standards that are published for Kubernetes right now. Obviously, IAM, and then communication in between services. Those can be secured with a service mesh like Istio or Linkerd or Conduit or one of those, and that is absolutely incredible. All of that was like a whirlwind. So if you can, use a managed service. There are people who are paid very well to make sure that everything is secured.
Don't do what we did.
We were in AWS before EKS is a thing. It's still not a thing. AWS, if you're listening, please.
Make it a thing.
But if you can't, then you can use a tool like Kops. It's great because you can version your cluster. It has an automated update and rollback strategy. Allows you to configure everything, but you're kind of on your own for issue diagnosis. And then it has a high management overhead. I mean, there's people who have full-time jobs now in companies to make sure that their clusters are alive. So with that, Kubernetes is good for Ygrene. Ygrene is great for the planet. You can come work with us. Thanks so much for you guys' time.
Good job, bro.
Looks like I have no questions on the Google thing, but if anyone wanted to raise their hand really quickly, I know it's time and it's lunch, so I don't blame you for just peacing out. Questions? How did Ygrene get to be amazing? Answer, just because.
It's all because of Zach.
Cool. All right, well, if you have questions, you can come find us over on the side. Thank you, guys.